Fourth video of this series. I'm Aaron Nightingale, owner of Nightingale LED Solutions and co-owner of the LED Costume Academy. I have over 10 years experience in wearable technology and soldering on the Las Vegas Strip. Hopefully you've watched the other videos of the series, and don't forget to hit that like button and subscribe for upcoming videos. And please feel free to leave a comment. We'll be focusing on splicing wires for your project. This is needed for extending or repair of wires or joining several wires together to branch to other areas in your project. These become very useful in wearable tech, and understanding the characteristics of all of them will help you decide which ones to use. If you want to get super technical into soldering standards, you can check out NASA-STD-8739.3, and I have the link available on my website so you can download your own copy. I will be walking you through some parts of these standards as I take you through these next few tutorials. I'll be sharing other standards with you throughout the series for you to look into as well. Let's get to the soldering. The first part of any type of soldering is tinning. The purpose of this is to prevent oxidation of the wire or tip and allow the solder to flow more freely when soldering together elements. This is incorrectly done by many people that I witnessed trying to solder. They will apply the solder to the iron tip and then move it to the material to heat and transfer the solder. This will move some solder, but the correct way is to tin the tip of the iron to promote heat transfer. Put the tip onto the material to heat and apply solder. Solder should flow freely into the material and not gather on the iron tip. If solder does pool on the tip and refuses to bond, it most likely means that the wire or material has dirt or oil on it and should be cleaned before soldering. Solder won't stick to a dirty, oily surface. I will be teaching you three types of soldered splices. A butt splice, which is the most basic electrical connection. The linesman splice, which in addition to electrical also offers a mechanical component, and knotted tap for branching a wire in the middle of another wire. I will be using a Series D or chisel tip for its surface area. We'll start with the butt splice. This is very similar to the standard crimp connectors that many have probably seen before. Comes in different sizes. Don't forget to add heat shrink before making your splices. The splice is the simplest to do and has electrical properties, but doesn't allow for any mechanical strength. If the solder joint doesn't heat properly and doesn't have enough solder flow or winds up with a cold solder joint, eventually the splice can fail. Additionally, many people who solder this type of joint don't strip enough insulation, which allows for the potential of solder creep under the insulation. Acceptable exposed wire without solder is less than 2 times the wire diameter, or 1.5 millimeters, whichever is larger. But the goal is 1 time the wire diameter to not leave too much wire exposed and eliminating solder creep. The correct linesman splice has 26 total steps to achieve aerospace standards. I will walk you through the process now, and then a modified version that I frequently use with wearables. If you'll have several splices next to each other, you'll want to consider staggering your splices to alleviate a large, bulky joint in the middle of your cable. I will again be using the Series D or chisel tip for this. I have my heat set at 700 degrees Fahrenheit. The larger tip type allows for a lower temperature on your iron as more heat flow is possible. Reminder that you want to use the largest tip possible for good heat transfer. To start out, we will strip the wire. Then we want to roll the wire to keep strands together. However, you will be introducing oils to the wire from your fingers. Clean the wire with alcohol to remove oil. We'll apply flux to the wire. Then we will cut a length of solder. We want to clean the solder with alcohol to remove oxidation. And then remove any alcohol residue with a chem wipe. We'll clean the iron tip with a dry chem wipe as well. Using our clean solder, we will lightly tin the tip of the iron, and then we will tin the entire length of the wire, stopping just short of the insulation. We'll clean the tinned wire with alcohol. And at this point, we want to place our heat shrink over the wire. We'll make our splice, so we'll cross in the middle, and we want 4 wraps per side. And you want to get these nice and tight. Trim off any remaining wire. We'll want to clean the connection again with alcohol. Apply flux to our splice. Cut another length of solder. Again, cleaning it with alcohol. And then we remove any residue with a dry chem wipe. Again, we will clean our iron with a dry chem wipe as well. And lightly tin the tip. Now we will solder our splice. Again, you want to put the iron on to transfer heat and then touch the solder next to the iron. We will again clean the solder connection with alcohol. And then we will inspect our solder connection. You should be able to see individual strands of wire. Here's where we will reapply solder if there's barrier areas, or remove large drops of solder. Just remember, if you do anything, we need to re-clean after we do it. Then we add our heat shrink. You want to shrink on the outside edges first. And then the middle, so it pulls tight. The reason that I use an alternate method is because when doing repair on wearable LED costumes, it is frequently the case that I don't have enough wire to do the full splice. So I will try to get at minimum 2 reps per side, so I still have some mechanical strength, as wires can easily get pulled while on stage or during dance sequences. This isn't always possible, so I'll get as many as I can and come back later to replace the entire wire. After soldering, you want to make sure that your heat shrink covers at least 2 times the wire diameter on both sides. There are heat shrinks with adhesive that can help make your joint water resistant as well. I find that the adhesive also helps to lock the joint, preventing bending at your solder connection. However, I find it is harder to do repairs if you use this type of heat shrink. The last splice I will go over is the knotted tap. This is good for if you want to wire a wire off. The challenge is that you need an exposed side to slide on the heat shrink, as you don't break the main wire, but it creates a very good mechanical bond before you solder, as it wraps over itself to create a hitch. You'll also need a steady hand to strip the insulation off the middle of the wire. You'll also want to follow steps from the linesmen in terms of cleaning the wire and tinning to get the best adherence. I've already stripped the middle of this. So we'll go ahead and tin both our tip and the wire. You'll start by placing your branch wire at about 2/3 on the full cable wire. You'll wrap to the short side and then over itself. And then you want to get 5 wraps on the other side. Again, cleaning our wire. Apply flux. And then cover with heat shrink. These are the 3 splices I recommend practicing and adapting to your wearables. I also highly recommend that if you add splices to your projects, especially quick repairs, that you come back and fully replace the wire later. Splices will always be the weak point, and most breaks are within a few centimeters of a splice, especially if the splice cannot be secured. Please join me for my next video on SMD and resistors, and I will see you there.